Welcome back, algebra students. Today we'll focus on factor by grouping. This method of factoring is mainly used when we have four terms. So anytime you see four terms, you're going to look to use factor by grouping. It is a very important method for the future here, speaking of tomorrow, because we will use this in what we call the AC method. There are three very simple steps to this method. One, you're going to group the first two terms and the second two terms. Once you have those terms grouped, you will then factor out the greatest common factor from each of the groups. You will do this independently. So you'll take one of the groupings, factor out the GCF, the other grouping, and factor out the GCF. Then you will factor out the common binomial factor. We have a few examples here to show you what we're talking about, so please follow along. Notice in the first example here, basically step 1 and 2 were already done for us. But what we want to look at here is notice how we have a common binomial factor here. It's almost like the GCF we did earlier. What do the two terms have in common? Well, these two terms have an x minus 3 in common, so what we're basically going to do is pull out that x minus 3, and if we divide each term by x minus 3, the leftovers would go inside the other set of parentheses. So what do we have left over here? 4x. What do we have left here? Minus 2. And that polynomial was factored by grouping. Now, not all of them will be like that. If you look at example 2, here you'll see we do have four terms. Okay, so the first step in grouping is to take the first two terms, group them, and then take the second two terms and group them. What we're going to do then is look at each of these independently. What is the greatest common factor between these two terms? Well, 2 and 3 do not have a common factor. But if you look, I have x to the third and x squared. Which one do we take, the highest or lowest exponent? Well, we tend to take the lowest exponent. So we're going to factor out an x squared. When I divide each of these terms by x squared, what do I have left over here? 2x. What do I have left over here? Minus 3. Now, from the second grouping, what is the greatest common factor here? Well, if I look, 4 and 6, the common factor would be positive 2. Okay, they both do not have an x, so I cannot factor out an x. So 2 is the GCF of the second grouping. But when I divide each term by 2, what am I left with here? Well, 4x divided by 2 is 2x. Negative 6 divided by 2 is negative 3. Now what you should notice here is we have something similar to example 1. We now have this polynomial of 4 terms broken up into a polynomial with 2 common terms, or factors I should say. The common binomial factor is 2x minus 3, so I'm going to pull that common binomial factor out, and when I divide each of these by that 2x minus 3, the leftovers will now go in another set of parentheses. What do I have left over here? X squared. What do I have left over here? Positive 2. And that is how that polynomial with 4 terms is factored. Now, we have 2 more examples down below. They work very similarly, but there are some things we have to pay attention to. So example 3 here. Notice again, I have 4 terms. That tells me I'm most likely going to look to factor by grouping. So I group the first 2 terms and the second 2 terms. Now the greatest common factor here is going to be n squared. So I'm going to pull out the n squared, and when I divide each of these terms by n squared, the leftovers would go in parentheses. Here I would have 6n left over. Here, n squared divided by n squared, anything divided by itself is 1. Now the second two terms, the GCF, well, 6 and 5, the common factor would be positive 5. They both do not have an n, therefore I cannot factor out the n. So 5 is my greatest common factor here. Well, what is 30n divided by 5 going to be? 6n plus 5 divided by 5 is 1. You know you did it right if you look at what you have done, after the first step, and your common binomial factor is the same. Well, what do I factor out here? The 6n plus 1. When I divide each of these terms by 6n plus 1, now what am I left over with? N squared plus 5. And that is now factored. The last example here has a pretty good example because it does something that other three examples did not do. Okay, when we group the first two terms here and the second two terms here, the first one is pretty easy. Okay, we know 6 and 2, the common factor is going to be 2. Then k to the third and k squared, we take the lowest exponent, so k squared. Now when I divide these by 2k squared, I know I'm going to have 3k, and then minus 2 divided by 2 is 1. K squared divided by k squared, they eliminate. Now the next part, if this first term here is negative, not only do we have to factor out the common factor, but we also want to factor out this negative from the first term. You do not want that first term to be negative. So when I look at this, I know I'm going to factor out negative. What's the common factor between 21 and 7? That would be 7. They both do not have k, so I cannot factor out a k. So negative 7 is what I'm going to factor out. Now, I am actually going to divide each of these terms by negative 7. That will change this. When I do negative 21k divided by negative 7, that would give me a positive 3k. 7 divided by negative 7 is actually negative 1. If you do not factor out that negative, you would end up with negative 3k plus 1, which would not match up with this binomial factor. So it's very important that if this first term, alright, let me highlight it, if this first term is negative, you have to factor out the negative with it. Well, now we have that common binomial term, so we factor it out, and when I divide each of these by 3k minus 1, the leftovers go inside. 2k squared minus 7. Now, a friendly reminder, anytime you want to check to make sure you're correct, all you have to do is multiply the binomials and make sure you get the polynomial you started with. If you didn't, you know you did it incorrectly. Hope you enjoyed it and learned something today. We'll talk to you tomorrow.